Recent explosive eruption. A Plinian eruption, one-third the size of the 1980 eruption of Mount St. Helens, sending measurable amounts of ash all the way into Montana. This occurred due to a sustained eruption column which rose up to a height of 21 kilometers or 69,000 feet. And yet, something is quite strange. This eruption did not occur at a stratovolcano or even a lava dome complex such as California's Lassen Peak, but rather something quite uncommon in the Cascade Range, a shield volcano. Specifically, Newberry's size, the Newberry Shield Volcano. Newberry is truly massive, with its main edifice and vents encompassing an area of 1,200 square miles or a little larger than the entire land area of Rhode Island. While yes, Newberry has produced a number of very powerful explosive eruptions, hence the big obsidian lava flow and its two-stage caldera, is primarily composed of highly fluid basalt and basaltic andesite lava flows. These lavas during eruptions can flow at speeds of up to 30 km per hour or 18.6 miles per hour and quickly cover faraway areas in a layer of molten rock. For example, in the year 5050 BCE, the eruption of the Lava Butte cinder cone would result in the emplacement of a 9-square-mile lava field, covering the outskirts of what is today the community of Deschutes River Woods, population 5,800. The reason for the combination of effusive or mildly explosive flank eruptions and highly explosive summit eruptions relates to the Newberry volcano having at least two separate magma chambers which each feed different types of eruptions. While this volcano as a whole not erupted since the year 690, it has seemingly averaged at least one eruption per millennia during its recent geologic history. To further elaborate on this point, here are the vast areas lava and volcanic vents have covered just simply in the Holocene epoch. Since any future summit eruption could generate damaging lahars which volcanic hazards descend Paulina Creek into the Little Deschutes River, it should come as no surprise that Newberry is classified as a very high-threat volcano. So, how exactly did such a massive shield volcano grow? Well, this is largely owed to both its high eruptive rate and old age. Newberry has erupted at a rate during its lifespan which is about 3.6 times higher than Mount Rainier or 73% higher than Mount Adams while at the same time being a whopping 600,000 years old. Early fluid eruptions. Geologic history of basaltic lava transitioned into both basalt and basaltic andesite, which spread out over a large area albeit with many vents aligned along a north-to-south trend. By 500,000 years ago, after thousands of eruptions meaning an average of more than one every century for 100,000 years, the Newberry volcano reached a monstrous height of 14,000 feet above sea level. However, one of its magma chambers slowly became more and more silica-rich until it triggered a major explosive eruption 300,000 years ago which was 19 times larger than the 1980 eruption of Mount St. Helens, causing the volcano to lose a significant amount of height and form a large caldera. This caldera would then further expand in a similarly powerful eruption 75,000 years ago, creating its modern 8-kilometer-long and 5.8-kilometer-wide depression in the ground now filled with its two large lakes. While eruptions within this caldera have largely been rhyolitic, eruptions outside the Northwest Rift Zone caldera began clustering along a north-northwest trend known as the Northwest Rift Zone. This rift zone has produced abundant purely effusive to moderately explosive eruptions in the time since, hence why the modern volcano is elongated along the rift's orientation. As a final note, I want to remind everyone that the Newberry volcano is statistically the most likely volcano to erupt next in the state of Oregon if we are talking based on its rate of Holocene eruptions. Also, I would like to thank my new patron Sardines R.S. for supporting this channel.